Tonight is to listen to this lecture on radioactive decay in the chapter that we're studying on nuclear chemistry. Please take your notes on your 2-column sheet that was given to you today in class as the computer retypes them, and you'll see it on the little note sheet. So we're going to start off today by talking about the different types of radiation that there are. The first type of radiation we need to know about is called an alpha particle. For each of these different types of radiation, they're going to have a name that's associated with them. That's a name you probably haven't heard before, or if you have heard it before, you probably had no idea what they were talking about. And that's because nuclear chemists tend to name their particles a little bit differently from what you're used to, because they want to make it clear that these particles are actually in the nucleus. So this alpha particle can be more commonly called a helium nucleus. So the symbol for this is going to look just like the helium atom itself. It's going to have a mass number of 4, atomic number of 2, and the symbol He. All of these different particles are going to have a charge associated with them. The charge of the helium nucleus, the alpha particle, because it's only the nucleus, means that there are no electrons present. Because its atomic number is 2, that means there are 2 protons present. We all know that a proton has a positive charge, so therefore the charge on this is going to be +2. With each particle that we talk about, we'll also mention the type of shielding that's required. And that's going to be the thing that you can use to block that particle from coming at you. So when a helium nucleus, it's a very big particle. The bigger the particle, the least amount of shielding that you require, because it's harder for something really big to try to channel through something, versus a little tiny particle can pass through very easily through different things. So because an alpha particle is a whole helium nucleus, this is going to be the biggest particle we talk about. Therefore, the shielding that you require for it isn't that big at all. So we're going to say just a sheet of paper is all you need to block this particle. The next particle we're going to talk about is called a beta particle. A beta particle you more commonly know as an electron. Keep in mind they're calling it by that different name because it's actually going to be in the nucleus, not typically where you think about finding an electron. Because it's just an electron and there's no protons present. You can tell that because up on top, for its atomic mass, it says 0. That means that there's no protons present and no neutrons present. Down on bottom, for the number of protons, it actually says -1 for its atomic number. And the reason for that is for an electron to be present, what ends up happening is a neutron splits into a proton and an electron. So its charge, because it's just an electron, is going to be -1. Shielding required, you're going to need a little bit more to block the actual beta particle because it's much smaller than a helium nucleus. You know, a helium nucleus has a mass of 4 AMU, whereas this beta particle has a mass of 0 AMU. So your shielding required is a little bit more. It's going to be lead. That's like those lead vests that they put on you when you go to the dentist and get your little X-ray pictures taken. The next particle is called a positron. And there's not really another name for this. You haven't been exposed to a positron before. But what it is something with the same exact mass as an electron, except instead of having a negative charge, it actually has a positive charge. So this charge is going to be +1. And the shielding required is going to be the same as the electron because it is the same size. Size is what's determining what type of shielding we need. The final particle that we're going to talk about is a gamma ray. And for this one, it's not really a particle. We called it a ray because it's more like a beam of light, like a ray that shined at you like a laser beam type thing. So we're going to say that this is a high energy photon for its description. And it doesn't really have a symbol of its own that we're going to talk about, and it also doesn't have a charge at all either. And this, because it's just a ray of light, like a high energy photon, it's going to require a lot more to be able to block this. So for this one, the shielding required, we're going to say concrete. Okay, those are our 4 particles that we'll talk about as we move through this. Also, during this, we will mention a neutron, which I'm going to add in here. And that's a particle that we already know what the neutron is, but it's valuable for you to know how to write, don't commonly talk about. So remember, neutron gets figured into your mass number. That's your top number. So your top number for a neutron is going to be 1. And then it's not going to have any protons, so your atomic number is going to be 0. And then your symbol for it is going to be N. Which, for some reason, the computer is not letting me put in the right spot, but you get the idea. So 1 on top, 0 on bottom, N. That's how you write a neutron. The next thing we're going to talk about is actually balancing nuclear reactions, which is really a kind of simple process. It's the easiest type of balancing that we'll do. So I made you kind of a quick little list of steps. So the first thing you want to do when balancing a nuclear reaction is treat the reaction like 2 separate math equations. And what I mean by this is when you look at a nuclear equation, you will see that there are numbers on top, all your mass numbers for all the different particles that you have that are in the reaction, and then the numbers on the bottom, which are all your different atomic numbers for what's happening in the reaction. So you just treat them separately, take care of your mass numbers first, and then take care of your atomic numbers, do them separately. When you're solving it like it's an equation, the arrow should be treated just like an equal sign in your math class. So that means as you're going, if things are added together, then you add them up on one side, and they should equal what you have for numbers on the other side. So you just want to pick one to solve at a time. So we'll say solve the top first. And I'll walk you through some of these in class tomorrow too to really make sure you have it down. And then the only trick to it is getting the symbol when you're all done. So we know that to determine the type of element, we always look at the atomic number. And that atomic number is our bottom number when we're looking at the symbol. So all you do once you solve for what you want there to get the symbol to fill in, is you look at that bottom atomic number, look for whose atomic number that is in the periodic table, and write the right symbol in. So find atomic number, I'll even write here, bottom number on periodic table, and fill in symbol. Okay, so that's all you have to do to balance a nuclear reaction, is you're making sure the numbers match, that they add up and equal each other on either side of the arrow, and then you're filling in the right symbol that matches up with your atomic number. I'm going to quickly show you on the PowerPoint what a couple of different examples of nuclear reactions that you should be familiar with them by name, so that you can identify them if they're mentioned to you by name on a test, look like. So the first one we're going to mention is called alpha emission. For these ones, it's probably best if you copy down the actual equation that's being shown to you on the PowerPoint side into your notes. I'm not going to copy that in because this program's not very good at doing the superscript, subscript thing and getting the symbols correct. But I will make a little note here about what type of thing it is. So for something that has the word emission in it, anytime something emits something, like if light is emitted, that means light's given off. So when we see the word emission, we're going to think of something being given off. So when it says something like alpha emission, notice how when you look at the PowerPoint, there's an alpha particle. Remember, alpha is the 4/2 He, and it's coming after the arrow, meaning that it's getting given off during the reaction. So I'll just write here, alpha particle after the arrow in the nuclear reaction. So if you see that, that's going to be an alpha emission. Sometimes they replace the word emission with decay, so if it says alpha decay, that would be the same exact thing as well. And don't forget to copy the little nuclear reaction you see in the PowerPoint. Okay, so the next two are, again, other types of emission, dealing with the other two particles that we have mentioned. So for the beta emission one, that's going to be where the beta particle shows up after your arrow. And remember, a beta particle is only an electron, so it's an electron coming after the arrow. And again, copy down the reaction from the slide so that you have the example. I'm just not doing it because of the capabilities of this program. And then the last one, not the last one, but the other one on the slide is positron emission. So again, because it says emission, it's coming after the arrow, and this time it's just a positron after the arrow. Okay, and I'd copy down that example equation as well. Alright, so moving on to our very last type of reaction. It's called electron capture. So here with electron capture, it now has, it's mentioning electron again, which is our beta particle in fancy nuclear terms. And capture means that it's going to be adding it in. Because if you capture something, you're adding it to your team, you're grabbing it, right? So here, that means that the electron is coming before the arrow. It's being added to whatever your first particle is that you're starting with. So here I'm just going to write, to know that it's electron capture, electron is before the arrow in the nuclear reaction. And again, I would write down the equation that you see on the slide in your notes as well. Gamma emission, we're not going to take the time to actually write down an equation for it, but that's any type of decay that gives off gamma rays. And that usually follows other types of decay. And it is the one that gives off the most penetrating types of radiation. And then there's a generic term here too. So let's fill this into your notes as well. So transmutation is just kind of a vocab word, and that's used for any time one element becomes another, which happens in most nuclear reactions. So anytime we change our number of protons, because remember the identity of an element is determined by the number of protons, we're going to see that happen, and we're going to call it transmutation. Okay, so you are now done with your homework for the night. I will see you in class tomorrow.